loading, and we can just get straight to it. Again, just a quick recap. At Tshepang, you will catch up as we do different sets of exercises. We spoke about Newton's first law and second law. First law, where it is now focusing on object that is at rest. When we say the object is now at rest, we are basically saying the object is stationary. It is not moving. However, there are forces that are acting on that particular object. Because it is at rest, it is not moving. All the forces that are acting there, they are in equilibrium. Or it continues to say continue to move at a constant velocity. So it will still move, but the forces that are acting on it are now still in equilibrium, unless acted upon by an external net force. That is when I said now consider a car that is now on a cruise control. The driver is not pressing any pedals or pushing any pedals. However, when they start seeing a cow trying to cross the road, what do, ladies and gentlemen? They start pressing the brakes, and then the car is now starting to change in terms of the forces that are being applied. That was law 1. But law 1 works together with inertia, and we defined inertia as the resistance of an object to change in its position of rest. So while you are sitting in that particular car, when they press the brakes, you move forward and go back. That is exactly what inertia is. Inertia is the resistance of an object to change in its state of motion. But there are factors that influence now inertia. The very first one is mass. The bigger the mass, the more difficult it is for the object to move from rest. But the very same law of inertia, as well as the one of Newton's laws, first law, we can apply that in our daily lives. First one will be safety belts as well as the airbags. How do they protect us in this motion of inertia? How do they allow us to incorporate inertia as well as Newton's first law? First things first, the safety belt reduces impact by increasing contact time between the passenger and the dashboard. So because you are going to move forward, the seat belt is going to pull you back. By so doing, we are saying it is increasing the contact time. And when they increase the contact time, the net force is reduced and the passenger will be less injured. It is as simple as that. Reduces impact by increasing the contact time. So you take longer for you to go to the dashboard. While you are taking longer, it is basically decreasing the net force. And when the net force is reduced, it means the impact on you is now becoming small. We further went to Newton's second law, where it said when a net force is applied to an object, the object will accelerate in the direction of the net force. What does the word accelerate means? It means it will move, but it will only move if it has now what? The net force. Now, acceleration is directly proportional to the net force, which basically means if acceleration is increasing, it means the net force is also increasing, which basically says when now I hit on the accelerator, the engine must supply a higher net force for the car to actually do what? To move faster as well. Hence, we say acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Ladies and gentlemen, inversely proportional. If I have a bigger mass, slower acceleration. If I have a smaller mass, bigger acceleration. I made an example of a truck filled with a lot of goods that must be transported. It will move very slow because the weight or the load is very heavy. However, if I want the load now to be smaller or remove everything, it means that truck, the mass is going to be reduced and the acceleration will be somehow very high. Ladies and gentlemen, the equation for Newton's second law is F net is equals to ma. What is F net is equals to ma? Ladies and gentlemen, F net means the total number of forces acting on an object. Acting on an object. So first things first, we must now identify all the forces that are acting on this particular object. If we are unable to identify all the forces, we will not be able to do what? To use F net is equals to ma. Hence, I elaborated here to say, for us to use that, we need to identify all forces that are acting on the object. And all forces acting on the object means what? Means we must draw now the new thing that we call a free body diagram. So a free body diagram, it is just a diagram that indicates the number of forces. Thank you. And I gave you a hint to say, if the examiner or the question says draw a free body diagram, check mark allocation. If it is 4 marks, it means you must draw 4 forces. This was just a basic summary. Difference between contact and non-contact. Contact forces arise from a physical contact between two objects. Non-contact arise even if two objects do not touch each other. And we made an example of 2 things here. The first one was a magnetic field between the magnets. They are not even touching, but there's a force because when you bring them closer, especially north and north, south and south, they actually push one another. So there's a force in between, but they are not touching each other. We made an example of you thrown vertically up. We made an example of throwing an apple up, but when it reaches a certain height, it falls automatically to the ground. And that it's because it's being pulled down by what we call the gravitational force. Ladies and gentlemen, we have 2 important forces that we need to be talking about. First one, normal force. Second one, gravitational force. These forces, they counteract each other. Normal force is applied by the surface. Gravitational force is now what the object possesses. Because the object has the mass of its own, automatically that object must experience gravitational force. For us to know now the difference between normal force and gravitational force is very easy. Normal force is applied by the surface and it is acting perpendicular. So as long as there's a surface, normal force must be there. The fact that the object possesses a mass, it means definitely what? The object must be experiencing gravitational force. So these are the 2 forces that you will always have. And remember, Fg, which is the gravitational force, ladies and gentlemen, will always act downwards. Normal force, I don't want to say it will always act upwards. I will say it depends on how is the object sitting. If the object is sitting somehow, we just need to check where is the surface, and now the surface, is it applying the normal force perpendicular to the object. That is very important and critical. Ladies and gentlemen, let me pause here, give you your 50 seconds to digest everything that we have done, and then we'll move to the next slide. Ladies and gentlemen, thank you very much. Then we spoke about frictional force. And we said frictional force is a force that opposes the motion of an object, which acts parallel to the surface. What does that mean? It means if my object is moving to the right, if this is the direction of the motion, frictional force will act in an opposite direction. Frictional force. It is as simple as that. However, we have two different types of friction. One, static friction. What is static friction? The force acting parallel to the surface and opposes the tendency of the motion of a stationary object relative to the surface. So static, what does it mean? Stationary, rest. So the object, when it is not moving, it possesses, ladies and gentlemen, what we call static frictional force when it is not moving. But if it is moving, it has what we call now what? The kinetic frictional force, the force acting parallel to the surface and opposes the tendency of a moving object relative to the surface. And we have a symbol to represent that, which is just Fk. I'm not going to bother you with this. We will do an extended example of today. This one we also explained, but I have a nice one that I want us now to be looking into. We are going to try and do it together. Let's check. Let's call this one number 10. I'm just going to draw a diagram. Okay, let's use the tools we have. Let's put it there. Have our block there, fill it with green, have an arrow in this direction, and we are told that this force here, it is a force of 15 newtons. That is what the examiners are telling me. However, the examiner says the block is pulled by a 15 Newton force to the left. on a rough surface. Now I don't want to write the questions as yet. I will just say the first one is draw. Okay, let's maybe do this one. The first one will be state Newton second law of motion. Now, what does it say? Newton second law of motion.
Just give me a minute. I'm just looking for. You said normal
Newton
Newton
second law.
or second law. You just give me a minute. Sorry. It says when a net force is applied to an object, the object will accelerate in the direction of the net force.
Thank you very much. But that is not enough, because remember, this is a definition and it will be 2 marks. So we need to tell this examiner to say when a net force is applied on an object, the object will accelerate in the direction of the net force, full stop. The second part now comes. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. You might be asking yourself, why did I use now 2 different color pens but for the same answer? It's because when we mark this part, what we do is we give you 1 mark for the part in red and 1 mark for the part in black. So if you are going to give us only half of the definition, we are only going to give you half of the marks. So what is important, ladies and gentlemen, in this instance is now what? It's now that you know your definitions fully and weight by weight. Because if you can lose the weight net, lose the weight direction of the net force, automatically you are going to lose the context of the definition itself. So definitions are very important for us to actually know and get the desired marks. Ladies and gentlemen, because I am giving this particular diagram, it means there are possible questions that are going to come. And remember, we said we have an analogy, state, use, and apply. Yes, Tsepang?
Sorry, sir, to disturb you. So I wanted to ask if this call is being recorded, because you said you're gonna record it in the beginning of the meeting.
Yes, I'm not recording on the app. I'm recording on another
Thank you, sir.
software,
Sorry.
so it will be available. Definitely, don't worry.
Thank you, sir.
Thank you. So we have a principle of state, use, and apply. The fact that the examiner is asking me to state Newton's second law, the expectation is now I must use Newton's second law. and most probably apply the principles of second law. So the fact that I am asked here, ladies and gentlemen, to say state Newton second law, the follow-up questions will be using Newton second law. But I did say we cannot use second law if we do not have now what? A free body diagram. So the first thing is, even if this examiner is not going to ask us to draw a free body diagram, I must draw a free body diagram. Why? Because a free body diagram is the indication to me in terms of the forces that are involved on the object. So I am going to write at number B and say draw a free body diagram. Free body diagram of all the forces acting on the block. Lehakwe, how many forces do we have?
4 forces.
We have now 4 forces. Why can we confidently answer that? We said the mark allocation indicates now the number of forces we have. It's very easy and straightforward. So if it was 3, I repeat, it will be an indication of us having now three forces. But now, do we have a surface? Yes. The examiner is telling us it is on a rough surface. So automatically the fact that it is on a rough surface, it means there has to be this force, there must be this force, and these forces, we write their names with capital letters, ladies and gentlemen. If it's small letters, you will be penalized. It's Fn for normal force. Remember, it is applied by the surface. If we have our surface here, it is applied by the surface perpendicular to the object. We are going to have Fg, which is now our gravitational force. What is the gravitational force? The force that now the F exerts on the body or on the object. Now, we have 2, ladies and gentlemen. And Lehakwe said we are going to have 4. How can we have 4 in this instance? Which other forces are there? I am told it is pulled by 15 Newton force. So I must have a force moving in this direction, and that force we are going to call it force applied. Capital letters, ladies and gentlemen, very important. At times I usually say fine, let's just do this and write the magnitude that is given. But I only have 1, 2, 3. Neo Mazibuko, His Excellency, which force is outstanding now here?
Isn't the force outstanding kinetic frictional force?
Kinetic frictional force. Because kinetic frictional force, this object is moving, we are told it is pulled on a rough surface. So the word rough, ladies and gentlemen, basically means that there is frictional force. But the fact that the object is moving, it means now what? It means that the object will possess what we call kinetic frictional force. Ladies and gentlemen, this free body diagram, Tepa, if we are failing to identify the number of forces, all our calculations are going to collapse. Why? Because we are going to base everything that we do, all the calculations, from this particular information here. Now let's Thank you very much. Now let's add one type of equation that they can ask us. We are only given 15 newtons. That is all that we have. So I am going to make this very complex and say, let's change the pen. The object is now moving to the left with an acceleration of 4 meters per second. 4 meters per second. The mass of the object is 20 kg. First question, calculate the magnitude of the frictional force. Let's change this, it's too big. Let's make it a little bit smaller. Let's make it something like 1,5 kg. 1,5 kg. Now the examiner says calculate the magnitude of the frictional force. Ladies and gentlemen, allow me to select everything here and just basically move it up a little bit. We have these equations. Equation number 1, Fk is equals to mu k F normal. Equation number 2, Fg is equals to mg. Equation number 3, F net is equals to ma. 1, 2, 3. Now when we check the information given, Fk is equals to mu k Fn. That equation will not assist us to get to the correct answer. Why? Because we don't know what is the value of mu k. So it means it is not going to assist. Second equation, it is going to give us Fg because we have the mass and we have g, which is 9.8 meters per second. But F net is equals to ma. It means now it includes all the forces that are acting on the object. So F net excuse me, F net is equals to MA. It is now what? The one which is more applicable for us to apply. So I am happy with my equation. F net is equals to MA. But I need now to identify the forces that are acting on the object, that are actually making this object to move to the left. Your Excellency, Mr. Mazibuko, is the object moving to the left, right, upward, or downward?
Left.
It's moving to the left. So, Lehagwe, what does that mean? Which forces am I going to work with? Am I going to work with horizontal forces or vertical forces?
You're going to be working with the horizontal forces.
Horizontal forces, because, ladies and gentlemen, this object is moving in the horizontal direction. So it means for me to work with F net, ladies and gentlemen, I must be able to say FA plus FK is equals to MA. Very, very easy. Very, very, very easy. But force is a vector quantity, which means it has a magnitude and as well as the direction. So if that is the case, it means we must assign direction to these vectors. So I'm going to say everything moving to the left is positive. Then I can substitute 15 minus FK is the unknown is equals to now what? 4 multiplied by 1 comma 5. Let me write it the right way. 1 comma 5 kg multiplied by 4. That is what we have there. Then I'm going to take my calculator and say 1 comma 5 multiplied by 4 is 6. So I am going to have 6 here. 15 minus FK. But now I must play around with the mathematics. I want to make FK subject of the formula here. Then I can easily say 15 minus 6 is equals to FK, and then 15 minus 6 is 9, FK is 9 newtons. But what is the direction of FK, ladies and gentlemen? The direction of FK, it must be now to the right. It must be to the right. Very, very, very important. So in the meantime, let me just duplicate the slide as we are going to add more questions to it. But the principle, ladies and gentlemen, is basically the same. The principle is basically the same. Why is it basically the same? Because everything that we are going to do, we are going to do it in such a way that you have now what? The correct free body diagram. The free body diagram is going to assist us in order to do what? In order to perform calculations, in order to see and check which equations are now most relevant for us to actually use. I'm going to give you your 50 seconds to digest everything and drink water. Then we will be able to say we can move now to the second part of the question. the application of second law is very easy provided you have a free body diagram. A free body diagram governs, ladies and gentlemen, everything that we do. A free body diagram governs everything that has to do with the calculations. So there is no way of you getting the calculations right if you do not draw the correct free body diagram. So a free body diagram is just a diagram that assists us in identifying all the forces that are acting on the object. Ladies and gentlemen, allow me to remove this part, and then we can build on it. Remember, you will have the e-notes of this session. Now let's go to number 2. Sorry, number 2 says calculate the coefficient of friction. What is the coefficient of friction? The coefficient of friction, they are basically referring to mu k. That is what they are referring to. Mu k. Now let's write down our equations again. Fk is equals to mu k F normal. F net is equals to ma Fg is equals to mg. Remember, the formulas will be given in the formula sheet. I am only writing them because of purpose of emphasizing. Let's look, ladies and gentlemen. What the examiners are asking here, it is this thing, mu k. So it basically says that is the only equation that I have that is going to assist me with mu k. However, I must still get my F normal. I have the friction, it's given, it's 9. Mu k, it's actually the question. So it basically says now my stumbling block for me to use this equation is to get the normal force. If I don't have the normal force, then it means this problem is not going to be solved. So now the question should be, Lehakwe, how can I get the normal force?
The normal force is normally equal to the gravitational force.
Thank you very much. Now it means I must apply the concepts of science. The concept of science that says when the object is sitting on the horizontal plane, Fn is equals to Fg only if the object is on a horizontal surface. Only when the object is on a horizontal surface. Then I can easily say Fn is basically just equals to mg. What is the mass? 1,5. What is the g? G is a constant, ladies and gentlemen. It will also be given, and G is equals to 9,8. And then 1,5, my calculator quickly. 1,5 multiplied by 9.8 1,5 multiplied by 9.8 gives us something like 14,7 newtons. This is now the normal force. Then I can confidently take the equation Fk is equals to mu k F normal. The fact that I have the F normal, it's easy. Substitute the 9 is equals to mu k is equals to 14,7. Divide by 14,7. Divide by 14,7. These two now will cancel each other, and then I will get something like 9 divided by 14,7 is equals to mu k is equals to 0,6. Now mu k, ladies and gentlemen, it does not have no SI unit. The question is, why does it not have the SI unit? This thing is just the ratio of two forces, and it is true because it's Fn, it's Fk divided by Fk divided by Fn is equals to mu k. So this thing here, it is just a fraction. So you are dividing Newton with Newton. That is the reason why you don't have any SI unit there. So because of that, it makes it now nice and easy for one to understand that the mu k will not have the SI unit. Now, questions please.
Nothing so far, sir.
Thank you very much. Sepang, any questions please?
I'm okay so far. Thank you.
Thank you very much. Lehakwe?
I'm also fine right now, sir. Thank you.
Thank you very much, and welcome to you, Boleng. Now let's try another one, ladies and gentlemen. Let's try another one. The one that we are going to try is we are still working with one object. This was number 10. Let's make this one number 11. Let's try another nice one. Another nice one says you still have the same object. Object on a rough surface is pulled or pushed or rolling into this direction with F A. We do not know what is that force. However, the examiner tells us that mu k is equals to 0,06. The mass of the object is 2 kg. The mass of the object is 2 kg. 2 kg. And then A is equals to 1,3 meters per second. Now the examiner just asks one question. Calculate the magnitude of the force applied. It's not asking a lot of things, it's just asking this question. Where do we start, Lehakwe?
First we find an equation.
First you find an equation. Can I say that is now step number 2? Where do we start, Neo?
So can you please repeat the question again?
Where do we start?
Yes, please. Sorry.
Yes, where do we start by trying to answer this particular question?
I think you should start by drawing the free body diagram.
Thank you very much. Lehakwe, Tshepang, Buleng, we start with a free body diagram. We cannot try to attempt any question on Newton's laws without having a free body diagram. A free body diagram is a guideline of how to approach this particular question. So Buleng, I'm going to put you in the spot and welcome you and say, how many forces do we have here?
We have a kinetic frictional force.
Kinetic frictional force. Thank you very much. What else do we have?
A normal force.
Normal force, because the surface is there. Thank you very much. F normal. What else do we have?
A gravitational force.
Gravitational force, because this body has its own mass. Fg. What else do we have?
Is it a frictional force?
Frictional force, remember it is Fk, which is now kinetic frictional force. And remember, I did say you cannot have static friction and kinetic friction. So if you have kinetic, it means you are done with friction. Then it must be another different force.
Is it the applied force?
It is the applied force, because the applied force is actually the one making this object to actually move. Thank you very much, Bule. Now that I have my free body diagram, I can go to my equations. Mu k, F normal, F net, ma, F g is equals to mg. Choice of direction, everything in that direction must be positive. Tshepang, is the object moving to the right or to the left?
It's moving to the right.
To the right. Thank you very much. Because it's moving to the right, Your Excellency, Neo, which forces am I going to work with? Am I going to work with horizontal forces or vertical forces?
Horizontal, sir.
Horizontal forces, because this object is moving horizontal forces. So now, let's check. Because it is Newton's second law, if I start with F net is equals to MA, F net is equals to MA, what is happening? I'm going to have FA positive plus FK is equals to MA. Ne, fine. Do I have the mass? Let's check. Yes. Do I have acceleration? Yes. Do I have FK? No, I do not have FK. FK is now what? The problem. Because FA is actually the question. So what is this saying to me? This is saying to me I must go and find frictional force first. I must go out and find frictional force. Where and which equation is for frictional force? The equation for frictional force is there, ladies and gentlemen. It's there. Let me correct it. Mu k F normal. That is the equation for the frictional force. So I'm going to start by saying let me first calculate the frictional force. However, I have a problem now. What is the problem? I do not know the magnitude of Fa, but because it is sitting on a horizontal plane, one can easily say fine, then it means Fg is equals to F normal, because now only on a horizontal surface. Then we move to say Fg is actually equals to mg. Then I can calculate my normal force. 2 multiplied by 9.8 is equals to Fn. Take a calculator. 2 multiplied by 9.8 is equals to 19.6 newtons. That is now Fn. But I do not want Fn. I want frictional force. Fk is equals to mu k F normal. What is mu k? 0.06 multiplied by 19.6. It will give us the value now of friction. Multiply by 0.06, it will give us something like Fk is equals to 1.176 newtons. But that is Fk, Mosne. It is not the applied force. So I'm going to go back and say F net is equals to Ma and force applied plus Fk is equals to Ma. Then the mass is 2, acceleration is 1.3, Fa we do not know, minus what? 1.176. Let me check. Now, do you understand why the negative, the answer there is Fa minus 1.176?
Yes, sir.
Why is that so?
Because basically I don't know how to explain it like in physics terms, but like in maths terms, basically you brought the positive side, basically the Fk equals 1/176, basically to the other side, which basically turned it into like a negative. Basically, I don't know how to explain it.
Okay, let's maybe ask Tsepang to assist you. Tsepang, do you understand why do you have Fa minus 1.176?
So I'm not sure why.
Okay, thank you very much. Lehakwe?
Um, Ish, I don't know. But
Thank you very much.
maybe FA would be equal
Okay,
to
bullying.
FK.
Do
I don't
you
know.
no? Thank you very much, Lahako. Bullying. Do you maybe understand why do you have FA minus 1,176?
So is it because um FA is like going towards the positive side and FK is in like the negative side of the free body diagram? As
100%.
in,
Yes, that is the correct answer. Ladies and gentlemen, remember we are working with vectors. So we chose to the right as positive. Right as positive. Very, very, very important. Majority of learners will lose marks because FNet means the sum. But when they come and substitute on this step, they forget to include the choice of direction. So the negative, ladies and gentlemen, is there because we agreed to say everything moving to the right must be positive, everything moving to the left must be negative. Hence we say friction here must have a negative sign. I did not answer it to say why. Bullying is saying because the free body diagram says FK is moving towards the negative, FA is moving towards the positive. That is very true. That is the reason why the free body diagram is there. So you use a free body diagram to support your answer, to support your reasoning, to support how you are going to calculate all this. Then we can do now what? The mathematical induction. Mathematical induction means FA is equals to 2 multiplied by 1 comma 3 is something like 2 comma 6 plus 1 comma 176, then plus 1 comma 176, and then our answer here it is 3 comma 78 newtons, which is true because what did we say? The object is moving to the right. So if it is moving to the right, it means FA, ladies and gentlemen, FA 3,78 newtons, FK 1,176 newtons. So FA must be bigger than FK for this object to move to the right. That is the reason why we went through this particular problem. But let's check, ladies and gentlemen. All these problems, they look like it's the same thing. Isn't it, Mr. Mazbuk? They look like it's exactly the same thing. But
Yes,
but when you check, the questions differ depending on what? On the information that is given. So the diagram that we're given 50,96 newtons. We move to this one, we are given 15. We are moving to this one also. That one we are given 2 kg. So, but the principle, if you check, is basically still the same. What does that mean? It means it depends on the information that is given. So don't try and memorize the science. You cannot, because the application will still be the same. Hence I said have that formula sheet. Always refer to the information that is given. The information that is given will assist you to do what? To actually have a way, a strategy on how to answer these particular questions. There is no way you can do it without having a free body diagram. Hence I said to Lahakwe, what is the first thing? So this is a catch from the examiner to say calculate the magnitude of the applied force. It's just a catch. Why? Because in a normal setup, the questions will be state Newton's second law, draw a free body diagram, calculate the magnitude of the force, and there will be that nice sequence of events or of questions. But this one, it will be around 6 marks, only because of the idea was to trick you to say, can you draw the free body diagram? Yes. Can you use the free body diagram to feed you with the information that you need? Yes. Because if you cannot draw the correct free body diagram, you will not be able to conclude and answer this part of FG is equals to Fn. You cannot. You only need a free body diagram for that, because the situations, ladies and gentlemen, are going to get complex. The situations are going to get complex and complex. Now we are dealing only with horizontal forces. I'm going to introduce now what will happen. Yes, we are pulling it horizontal, but let's have a situation, ladies and gentlemen. Let's have a situation, ladies and gentlemen, where we say, now this is number 12. Force, come on, force applied at an angle. I'm still going to have my surface, still going to have my surface, still going to have my object, but instead of pulling it horizontally, I am applying the force now at an angle, and it makes an angle, that we call theta, and it is force applied. Let's say it is also on a rough surface. Fine. One quick question. Bullying, how many forces do we have?
We have the gravitational force.
Okay, let me draw while you are giving us that free body diagram, because you cannot draw without, you cannot answer without having
This
the free body diagram. So you said FG is there. Yes, FG is there, I agree. FG, what else is there?
is there an applied force?
There is an applied force. Is it acting at an angle or is it horizontal?
At an angle.
At an angle, so it means it must move there, and then we say this is our FA. Thank you very much, Bullying. Lehakwe, give us the extra 2 that is remaining, please.
The natural force, and then
There, I lost you.
normal force.
Or the normal force. The normal force. Okay,
Yes,
because we have the surface. That is the reason
yes.
why the normal force is there. So let's have the normal force. Phi. F normal. What else?
saying the kinetic frictional force.
Kinetic frictional force, because we are told that it is now moving into a rough horizontal surface. Ladies and gentlemen, this thing here, it is 100% correct. 100% correct. Believe you me, 100% correct. But we have a problem now. The examiner tells us that this object is moving direction of motion. The examiner is telling us now that, but this object, ladies and gentlemen, it is not moving most in the direction of the applied force. It's actually moving horizontal. I maybe make an example of the people that are recycling things that you see everywhere in town. They are pulling those big bags of recyclable material, but that object is pulled at an angle, but it's not moving at that angle. It's still moving horizontal. Is it true, Sepa?
Yes, sir.
It is still moving on the tar road. So what does that mean? It means this force applied, it's not the one that is actually making it to move. Do you agree, Mr. Mazibuko? They are pulling it with their
Yes, sir.
ropes, but it's moving horizontal. It is still intact with the ground. Why is it not moving up in the direction of the force applied, but it is moving horizontal? It is still stuck on the tar road. Do you agree?
Yes, sir.
Now, can we agree to say this force, which is the force applied, it's not the one that is actually making that object to accelerate? It means we have something that we now call components of a force. Components of a force. So once the force is applied at an angle, ladies and gentlemen, we are going to have what we call components of a force. What are components of the force? We have a vertical component. Vertical component will be sine of theta is equals to FV for vertical component over F applied. Then we can say, but we want FV, so FV is just equals to FA sine of theta. That is now one equation that I want you to now think of and just know. Because why? Because this one will not be given in the formula sheet. Then we say fine. We are going to have horizontal component. Horizontal component. The horizontal component, ladies and gentlemen, is now what? Cos of theta FH over FV. Then it means, not FV, sorry, F applied. Then FH is just FA cos of theta. That is now the components of a force. So it means we have a vertical component as well as a horizontal component. So ladies and gentlemen, this is something very important that you must now know and consider. But what does this mean? In the exam, I want to write it down. Exam, the one that I'm going to draw is for calculations. So in an exam, ladies and gentlemen, you draw this one. But it's going to be the very same one, but the examiners don't want you to draw the next one. The next one that I'm going to draw is just going to use freehand. Fn, we said we have vertical component. Vertical component, we call it Fv. We go down, we still have Fw. We have F horizontal, Fh, and we have now what? Fk. Ladies and gentlemen, this is only for the purpose of the exam. In actual essence, what have I done? I broke down this into its component. So in actual essence, Fv and Fh are components of what? Of Fa. We agreed that you are pulling, yes, but the object is still moving horizontal. Why is it moving horizontally? It is because of the component that we call Fh. Now, when you look at the one for the exam, it's going to mislead us in terms of calculations. Why? Because if I want to work with vertical forces, can you see now that I no longer have Fn and Fg? Lehakwe, can you see that I no longer have Fn and Fg? I have Fn, Fv, and Fw to consider. Can you see that?
Yes, sir, I see.
Thank you. So now, the majority of people in the exam, when the force is acting at an angle, the mistake they do, they draw this one of the exam. 100%. They will get 4 out of 4. But this one that we are giving to the examiner, because they don't want the one of calculations. This one of calculations, you draw it separately on the question paper or wherever you are scribbling. Ne? Why do you need this one? You break it down into components because this is going to assist you. Bullying, can I say Fw is equals to Fn in this case, like we did with the previous one? Can I say that? Fn is equals to Fw. Can I do that? Is it allowed?
Yes, sir, because Fw is the same as Fg,
Now,
and Fg.
thank you, but that is not entirely correct. Let me tell you why. Remember, we looked into our free body diagram. Let me highlight that in blue. The one in blue here, we only have two forces, which is Fn and Fg. So they must be equal, you understand? Because those are just only two forces. But when you come to this one, after breaking it down into its components, the highlighted blue, we have Fn, Fv, Fw. So what does this mean in actual sense? It means when I look at my forces, Fw is equals to Fn plus Fv, because I'm now working with three forces instead of two. Why? Because I have introduced the component. The component of what? The component of a force, which is now what? Fv. So if I want to say Fw is equals to, I'm just going to check, is it moving up or down? It's not moving, it is still intact with the ground. So it is because of Fn plus FV. So this, ladies and gentlemen, where does it come from? From a free body diagram. I did not think of anything here. However, what I did was very simple. It's just to draw the correct free body diagram with now the components. And that was the aim of today's lesson, to show you that we can have an angle, or we can have forces applied horizontally, but we can basically just change it and say, let's apply this now at a certain particular angle. When we apply it at an angle, then we are going to resolve that into its components. So once there's an angle, remember, you are going to have vertical component as well as horizontal component, because they are not given in the exam, ladies and gentlemen. What you do is very easy. Just remember, FH is basically F cos theta, FV is basically F sine theta. That is all that you need to know from this particular slide. We are going to have two free body diagrams. The one that we write in the exam, because they don't want the one with calculations, but the one with calculations assist us actually to see which forces I am working with. Ladies and gentlemen, it is exactly 1925. So I'm just going to ask Bullying and Neo to give us the reflections of the day, and Tepam, maybe you must close it for us for your reflections, as well as your expectations are met for being here. Bullying, let's start with you, lady.
As much as I joined the class late, I actually caught up, and it is like I actually understood what was happening and what you were explaining.
Thank you very much. Your Excellency, Mr. Mazibuko.